Hello guys, welcome back to the channel. In today's video, I will teach you how to build your own blockchain from scratch using your most popular programming language or a subset of it which we all call TypeScript. Have you ever wondered how a cryptocurrency like Bitcoin works? Yes, you might know how to use and interact with the Bitcoin blockchain, but deep down inside of you, are you sure you understand the internal design of such a blockchain, like the one that powers our most popular cryptocurrency? If you want to know how to build your own blockchain from scratch, then absolutely smash that like button and subscribe to the channel. Turn on the bell notification to get access to all our videos as they drop. This video will be part of a series of videos I will be releasing this October on the channel. We will build a complete blockchain network with an inner blockchain, a P2P server, and a command line interface for interacting with the blockchain and the P2P server. In today's video, we will, however, focus on building the underlying blockchain that will power the network, and as such, we will consider the following talking points in this video. We are going to use TypeScript for this project, and this project is going to rely on several key libraries. We are going to use the Node crypto library for hashing. We are going to use the elliptic library for elliptic curve cryptography. This is used in key generation and transaction signing, critical for Bitcoin and Ethereum compatibility. That is, it allows our blockchain to behave similarly to Bitcoin and Ethereum. We are going to use BIP39 for generating a mnemonic, which is a 12-word recovery phrase and a cryptographic seed for our wallet. Now, we are going to have a transaction class that is going to define how value is going to move on the blockchain, and this will be responsible for proving the authenticity of transactions on the blockchain. We are going to have a block class which is responsible for aggregating transactions and implementing the proof of work mechanism. We'll have a wallet class, and the wallet class is going to be responsible for managing the user's digital identity and fund transfer initiation. We'll have a blockchain class, which is the core ledger, consensus, and economy manager. So let's dive into the code. First of all, I will generate a tsconfig.json file where I will paste in some config, and then I will generate a package.json file using the npm init-y command. After that, I will run npm install crypto, elliptic, ws, express, commander, readline, and bit39 to install all of the packages that will help us with building the application. And after that, I also install tsnode. We import crypto from the node crypto library, and then I will import elliptic from elliptic. I will import server from ws. I will import express from express. I will import command from command. I will import readline from readline, and then I will import star as bit39 from bit39. Next, I will create a new instance of elliptic.ec. This allows us to handle elliptic cryptographic function. This will greatly simplify the process of creating a key pair. The SECP256K1 is a standard elliptic curve widely adopted and used in cryptocurrencies like Bitcoin and Ethereum for key generation, transaction signing, and signature verification. Then I will create a new class, transaction, which will handle transactions on the blockchain. I will add a constructor function, and on that constructor function, I will add a public from address, which will be a string or null. I will add a public property to address, which is a string, a public property amount, which will be a number, a public property signature, which will be a string, and a data property, which will be of any type. Next, I will implement a calculateHash method, which returns a string, and this function will be responsible for calculating the hash of a transaction. Inside the function, I will return a call to crypto.createHash using the SHA-256 as the hashing algorithm. Then I will change the call to the update method, passing in the from address, the to address, the amount, and the JSON string from the data attached to the transaction. Then I will chain a call to the digest method with hex as the argument for the digest function. I will add another method, signTransaction, which accepts an argument signing key, which is of type elliptic.ec.keyPair. The name of this method implies its responsibility. Inside the function, I will check if the from address has a value and that the value of the from address is equal to the hex generated from calling the getPublic with the hex on the signing key. Then I will throw an error. You cannot sign transaction for other wallets. I will calculate the hash of the transaction and use the sign method on the signing key to pass in the generated hash as the first argument and base 64 as the second argument, then store the results returned inside of a variable sig. Then I will set the signature of the transaction to be the result of calling the to der with hex on the sig. Next, I will add a method isValid which returns a boolean, and inside the function I will check if the form address is null and return true from the function. Next, I will check if the signature of the transaction is not null or an empty string and throw an error, no signature in this transaction. I will create a public key variable by calling the key from public, passing in the from address and hex as the argument. Then I return a call to the public key .verify, passing in a code to this calculateHash and the signature. Now we are done with that. Let's go ahead and test this class out by creating an instance of a transaction class. The from address will be a string addr1, the to address will be a string addr2, and the amount will be 1000. And then I will console log the hash of the transaction by calling the calculateHash method on the transaction, and you can see the hash of the transaction in the terminal. I will create a new class block. I will declare a public nonce property which is a number, a public hash property which is a string. Then I will add a constructor function, and I will declare a public timestamp property which is a number. I will declare a public transactions property which is an array of transactions. I will declare a public previous hash property which is a string. I will declare a public difficulty property which is a number, and inside of this function I will set this .nonce to be equal to 0, and then the hash will be the result of calling the calculateHash function, and then I will have to implement this calculateHash function. Inside the calculateHash function, I will return a code to the crypto.createHash with SHA-256 as the hashing algorithm. Then I will chain a call to the update method, passing in the previous hash, the timestamp, and then I will pass in a call to JSON.stringify with the transactions in the block. Then I will add the nonce and the difficulty as arguments to the update method. I will chain another call to the digest method with hex as the encoding format. I will define a new method, mineBlock, which accepts an argument difficulty, which is a number. The mineBlock method finds a cryptographic hash for the block that meets a specific difficulty target. Inside the function, I will define a target which creates a string of zeros with length equal to the difficulty. That is, if difficulty is equals to 3, it is going to create a string with 3 zeros. Then we will add a mining loop. This will be a while loop, and inside the condition, I will get the first difficulty characters of the hash and check if these characters match the target 0. If there is no match, I will increment the nonce, recalculate the hash with the new nonce, and repeat this loop again until a matching hash is found. The nonce is the only part of the block data that can be easily changed. Changing any other data, that is changing the transactions or the timestamp or the previous hash, is going to break the blockchain. You should know that each nonce change produces a completely different hash due to the avalanche effect of the SHA-256. I will just log out a message to the console, block mined with the hash of the block. Next, I will add a method hasValid transactions which will return a boolean. Inside this function, I will loop to the transactions of the current block, and if any of the transactions in it is invalid, we will return false from this loop, effectively ending it along with the function. Then I will return true from the function if all transactions are valid. I will test this out by creating an instance of a block. The timestamp will be the current timestamp. The transactions will be an empty array for now. The previous hash will be a string 0 and the difficulty will be 2. Then I will console log a string initial hash with the hash of the block, which you can see from the terminal. Then I will mine the current block. The difficulty will be 2, and I will console log the hash of the block and the nonce, which you can see in the console. Now we are done with that. We need to create a wallet, and for that I will create a new class wallet. The wallet class is the digital identity manager of your blockchain. It handles cryptographic key generation, security, and transaction signing. Inside this class, I will add a public key property which will be a string, a private key property which will also be a string, a mnemonic property which represents the 12 key phrases you use for your crypto wallets. Then I will define a name property which will also be a string. I will add a constructor function. This constructor function will accept 2 arguments, name which is a string and password which is also a string. Inside the function, I will set the name of the wallet to be equal to the name argument, and then I will generate a 12-word recovery phrase using the BIP39 standard. I will convert the mnemonic into a cryptographic seed using the PBKDF2 with 2048 iterations to make brute force attacks difficult. The seed is a deterministic starting point. That is to say that the same mnemonic phrase will always produce the same seed. Then I will derive the private key by hashing the seed using SHA-256. This is a simplified approach. I will generate a key pair using the elliptic curve cryptography SECP256K1, which is same as what Bitcoin and Ethereum use. And from the key pair, I will obtain the private key, which is a random 256-bit number. I will also retrieve the public key from the key pair, but you should know that under the hood, the public key is derived from the private key using elliptic curve multiplication. Lastly, I will add an optional encryption where I will encrypt the private key with a password if a password is provided. Now, we need to implement this encrypt private method be used for encrypting the private key with the password. This method will accept two arguments, the private key and the password. Inside the function, I will create a cipher using the password as the secret key. Then I will encrypt the private key with the cipher and return the results from the function. Next, I will implement a decrypt private key method which accepts a password which is a string, and inside the function, I will add a try catch block, throwing any error encountered in the catch block. While in the try block, I will create a decipher IV from the password and use it to decrypt the private key and return it from the function. Then I will add a get address method. After that, I will add another method, create transaction, which accepts 4 arguments. The address, which is the first argument. The second argument is the amount of funds we want to send. The third argument is the blockchain we want to register the transaction on. The last argument is an optional password if any was attached when creating the wallet. Inside the function, I will retrieve the balance of the address we are sending from, and I will check if the balance is greater than the amount we are trying to send. That is to prevent us from having negative balance. Then I will retrieve the private key, and if there's any password attached to the wallet, I will use it to decrypt the private key. Then I will convert the raw private key string into an elliptic curve key pair object. This enables mathematical operations needed for digital signatures. It uses the same SECP256K1 curve as Bitcoin/Ethereum. Then I will create an unsigned transaction with from address, your public key, which is the address you are sending from, the to address, which is the recipient's address, the amount, and then I will call the signTransaction method on the transaction to create a digital signature with a key pair and return it from the function. The blockchain class is the core engine that is going to power our entire cryptocurrency manager. It manages the ledger, validates transactions, creates new coins, and maintains network consensus. Inside this class, I will add a chain property, which is the actual blockchain, which is the immutable ledger. I will add a pending transactions property, which is unconfirmed transactions waiting for mining. I will add a mining reward property, which is the incentive for miners. I will add a difficulty property, which is the mining difficulty, that is the proof of work target. I will add a nodes property, which is the network peers for decentralization. I will add a wallet registry property, which is a map object for storing human readable wallets. And lastly, I will add a max supply property, which is the hard cap of coins. Next, I will add a constructor function, and inside this function, I will initialize the chain with the genesis block because all blockchains need to start with the genesis block. Then I will set the pending transactions to be an empty array. I will initialize the mining reward to be 10,000, but dividing this by 100 gives us 100 net coin in base units. I will set the nodes to be a new empty set. The wallet registry will be a new empty map, and the max supply will be set at 10 million net coins. Next, I will implement the create genesis block method, which we will use to create genesis block in the constructor. And inside this method, we will just hard create a new block. This is the foundation of our entire blockchain. This hard coded starting point that every node agrees on with no transactions. Then I will implement a get latest block method, which returns the latest block that was added to the chain. I will implement a get total supply method, which returns the total supply of coins on the blockchain. I will implement a get remaining supply method, which calculates and returns the remaining supply of net coins available for distribution. Next, I will implement another method, the mine pending transactions method. This method is the heartbeat of our cryptocurrencies economy. It is where new blocks are born, miners get rewarded, and transactions become permanent. Let me break down this crucial process in detail. This method turns pending transactions into a permanent block and rewards the miner with new coins. First, I will retrieve the remaining supply and check that the 10 million net coin card cap has not been reached. If it has been reached, I will console log max supply reached. No more coins can be mined. Then I will calculate the actual reward. I will create a reward transaction using the mining reward address and the actual reward and push that into the pending transactions. I will create a new block with the pending transactions and the hash of the latest block. And after that, I will mine that block and console log block successfully mined with the reward. I will add a new method, add transactions, which accepts a transaction. Then inside the function, we check if the transaction has a valid from address and a valid to address. If not, I will throw an error. Transactions must include a from address and a to address. Then I will check if the transaction is valid, and if not, I will throw another error, cannot add invalid transactions to the chain. Then I will retrieve the balance of the from address and check that the balance is greater than the transaction amount. Otherwise, it will throw an error, not enough balance. I will push the transactions into the pending transactions array, and then I will add a new method, get balance of address, which accepts an address which is a string. Inside it, I will create a variable balance which is 0 and stores the balance. Then I will loop through the block in the inner chain, and for each block I will loop through the transactions in the block, and if the address the coin was sent from matches the current address, then I will add the amount to the balance. I will also check if the address of the receiver matches the address and add the coins to the balance. Then I will return the balance from the method. I'll add another method, is chain valid, which loops through the chain, and in the loop we retrieve the current block and the previous block. If the current block has an invalid transactions, I will return false. If the hash of the current block is not equal to the result of calculating the hash of the current block in real time, I will return false. If the previous hash of the current block is not equals to the hash of the previous block, I will return false. And outside the loop, I will return true. Next, I will add a method, register wallet name, which accepts two arguments: name, which is the name of the wallet, and an address with which the name will be linked to. Inside the function, I will check if the wallet registry has a wallet with that name, and then we throw an error, wallet name already taken. If everything is fine, I will add the address to the wallet registry with the name attached to it. I will add another method, get address by name, which accepts a name argument. And inside this function, I will get the address by the name and return it from the function. I will add another function, add node, which accepts a node argument, which is a string. Then I will add a try catch block, and inside the try block, I will construct a URL from the node and add the host to the nodes in the blockchain. In the catch block, I will just console log invalid URL. I will add another method, replace chain. I will retrieve the length of the current chain and then create a new variable chain which stores an array of blocks. I'll loop through the nodes in this dot nodes and add a try catch block. Inside the try block, I will make a network request to each node's chain, retrieving the chain return from the response and using that to calculate the length of the response chain. I will check if the length of the chain of the current node we are iterating over is greater than the length of the original chain, and if that is the case, we will set the max length to be equal to the length of the chain of the current node we are iterating over and set the new chain to be equal to the current chain. In the catch block, I will console log error fetching from node with the URL of the node. Aside the for loop, I will check if the new chain variable is valid and assign the chain of the blockchain to be equal to the new chain, and then I will console log chain replaced. I'm going to go ahead and test this out by creating an instance of the blockchain. Then I will console log the hashogenesis block, which can be obtained from the inner chain. Since it is the first block, we can use the index of 0 to get access to it. Next, I will obtain the total supply and console log it. I will also obtain the remaining supply and console log it. I will check if the block is valid and console log it. And finally, I will console log the length of the chain, Remember that we have not tested the wallet, and for that I will create an instance of a wallet. The name of the wallet will be Sam. Then I will console log the address of the wallet. I will also console log the 12 key phrase which you can see in the console. Now, we have not yet tested all of the methods on our blockchain, like creating transactions and mining, but don't panic, we'll do all of that as it progress. I just wanted to show you what's possible because, like I said, this is the first video, okay? In our next video, we are going to work on adding a P2P server that's going to allow nodes to communicate with each other, okay? If you like this video and you found it useful and interesting, then absolutely smash that like button. Ensure you subscribe to the channel and turn on the bell notification to get access to all of our videos that is drop. And I'll see you in the next one.